Assalamualaikum and very good morning to all the judges and participants for CITRES. My name is Nur Hafizah Saidan and I'm from the Faculty of Agro-Based Industry, UMK Jeli Campus. Today I would like to share my research finding entitled The Effect of the Cengawuch, Neobalanocarpus hemir on the physical, chemical and antimicrobial properties of coconut sap, Coccus nucifera. So this is all my colleague or co-researchers for this research. As an introduction, Coccus nucifera is belong to the family of Aricaceae, which is an important member of the monocotyledons. There are many products that can produce from the coconut tree, and one of them is coconut sap. Coconut sap, or locally known as nira in Kelantan, is a sweet natural traditional beverage obtained from the flower of the coconut tree. The coconut sap is enriched in sugar content, including sucrose, glucose, and fructose, that easily to enhance the fermentation process, especially when direct with this sunlight. Over-fermentation of this beverage may cause diarrhea, hernia, and also headache. Thus, it is crucial to control and slow down the development of the fermentation process. For the problem statements, from the public point of view, coconut sap has many nutritional properties and medicinal uses. The demand for this natural beverage is increasing, especially in rural area because of the availability of the product itself. Over-ferment of coconut sap may change the coconut sap to the alcoholic drink. The use of chemical preservative may change the flavor, texture, and color of the coconut sap. Hence, this study was performed to evaluate the effect of cengawuch as a natural antimicrobial agent to control or slow down the fermentation process in order to prolong the shelf life of the coconut sap. For the objective, we have two objectives. Number one is to evaluate the effect of cengawuch chip as a natural preservative on the physical chemical property and volatile organic compounds of the coconut sap. And second is to determine the effect of cengawuch chip as a natural preservative and on the antimicrobial property of the coconut saps. So for the materials and methods, number one, sample collection. The coconut sap was collected by tapping the unopened inflorescence of the coconut tree at Salo Pasir Mas, Kelantan. So common practice by the farmers or coconut sap collector, they will add a few cengawuch wood chips in the container in order to avoid the spontaneous fermentation, which can change the taste and odor of the coconut sap. So for this work, before collecting the coconut sap, the container has been washed and the container have been divided into two parts, namely coconut sap with the presence of the cengang and also without cengawuch chips in the containers. The coconut sap was collected in the morning and in evening session in order to avoid the spontaneous fermentation. The coconut sap was brought back to the UMK lab for storage in the sterile bottle at two different conditions, which is 25 degrees and 4 degrees until further use. The samples was evaluated for its physicochemical properties, including pH, acidity, total soluble solid, color, and VOC for 10 weeks. In order to determine the effect of the cengawuch in coconut sap. Next, for the second objective for microbial analysis, it begin with the extraction of the cengawuch chips using two solvents, which is ethanol and methanol. So the screening of the antimicrobial was used the distribution method. So after that, the coconut sap with and without cengawuch chip were tested for the presence of the microbe using total plate count for 10 weeks. Next, we proceed to the results and discussion. Table 1 showed you the yield of ethanol and methanol extract of the cengawuch chips using an ultrasonicated water bath. From this table, it showed that the methanol extracts yield was higher rather than the ethanolic extracts with the results of the 17.06, and while the ethanol is 13.60%. Next, the result for the pH levels of coconut sap during the storage conditions, 25 and 4 degrees Celsius for the samples with cengawuch chips and without cengawuch chip for 10 weeks observation. Commonly, the coconut sap pH value is 7. From the tables, the pH result obtained from the coconut sap with and without the presence of the cengal wood chips is 6 plus minus 0.01 and 4 plus minus 0.01 respectively. However, after week 3 and the rest, the pH value gradually decreased for all samples stored at 25 and 4 degrees Celsius. This is happened because of the fermentation process has been occurred in all samples, but very slow for the sample with the with cengal wood chips stored at 4 degrees Celsius. Next, we go to the result for the titratable acidity of coconut sap. Okay, the total acidity for both samples increased gradually, but very slow changes in 4 degrees storage condition for sample added with the cengal wood chips. This result was was confirmed by the pH analysis, where at the pH drop, the acidity of a coconut sap increased due to the activity from the lactic acid bacteria in the fermentation process. Next is the result for the total soluble solid of coconut sap. From this table, it showed that the TSS for coconut sap with a cengal wood chip at 25 degree and 4 degree Celsius decreased gradually until week 10. The result for the sample stored at 4 degrees with the presence of the cengal wood chip showed a fluctuation of TSS, and it is might be due to the utilization of the sugar for energy conversion into another substances, and it might affect from the presence of the bacteria and yeast. Next is the color analysis of the coconut sap with and without cengal wood chip at different storage condition. Where in this analysis, the main observation is on the lightness value of the coconut sap. The lightness of the coconut sap with and without cengal wood chips was increased from week 0 to week 1, but gradually decreased for both temperatures. The decrease of the lightness happened because of the reaction during the fermentation process, which lowered the intensity of the lightness of coconut sap, and it is also might happen due to the enzymatic browning reaction of coconut sap during the collection process. Next is the volatile, the result for the volatile organic compounds in coconut sap with cengal wood chip at 25 degrees and without cengal wood chip at 25 degrees. So, based on the analysis on the table 6 and table 7, there were 10 compounds identified in coconut sap with the presence of cengal wood chips, while 11 compounds were detected in the coconut sap without the cengal, stored at 25 degrees. They were divided into 5 classes of compounds, namely organic compounds, aromatic, hydrocarbon, fatty acid, alcohol, and alkane. For the sample stored at 4 degrees, which is on table 8 and 9, there were 8 compounds altogether identified in coconut sap with a cengal, and 9 compounds were identified in sample without cengals. So, for the table 10, which is the result for the microbial counts of coconut sap with and without cengal wood chip in 2 different conditions from week 0 to week 10, we use 2 types of the agar, which is MRS agar and MEA agar. Based on the table, MRS agar has showed that the value of total plate count of resulted 1.55 times to the power of 3 CFU per mil, while in coconut sap without cengal wood was recorded as 2.8 times to the power of 3 CFU per mil. In MEA agar, the result showed that the coconut sap with and without cengal wood chips on the week 0 as too few to count. After week 1 to week 6, the sample still showed the results below the acceptable limit, which is 10 to the power of CFU per mil. For coconut sap with a cengal at storage of 4 and 25 degrees after week 7, it showed that the result of the showed too numerous to count as the colonies were filled on the agar surface. However, from this analysis, it showed that the sample with preservative, which is a cengal wood chip, showed a slower microgrowth in both conditions for both media compared with the sample without preservative, which is cengal wood chips. So the last tables or the last result is for the screening ethanolic and methanolic extract against the test microorganism using paper diffusion methods. Based on this table, the screening of the antibacterial activity for ethanol and methanol extract has shown that both extracts successfully inhibit the growth of the microorganism at concentration of the 100 microgram per ml. So, in conclusion, for this research, the coconut sap with the presence of chengal wood chip as a natural preservative showed positive results toward its physical, chemical, and antimicrobial properties compared to the coconut sap without the presence of the chengal wood chips. With the use of chengal woods during harvesting coconut sap, it is proof that the fermentation rate is lower compared with without the adding the chengal wood. Thus, this study proved that the addition of chengal wood chip as a natural preservative during the harvesting of coconut sap improved the coconut sap properties and its shelf life. So this is all the references used in this presentation. So thank you from me, Dr. Hafiza Saidan from Fiat.